I want to start out, given kind of the snowfall situation, I want to start with this map because I've been looking at it fairly often over the last kind of few days. This was after the winter storm that had came through the, oh, did that disappear? There we go. There we go. This is the snow swath we had from roughly El Paso, Texas, as that winter storm came through, all the way up through New England, 6 to 8 inches of snow, right in the middle of the heart of winter, right in January. And this is areas we typically don't see a lot of snowfall, but there's an area kind of missing here from the satellite. A lot of that white you can see from Texas up through the Midwest into New England. That's snow, that's not clouds. But we're missing it in the plains, the central and northern plains. Acreage that's right around here. It's been kind of a common theme this winter, something I'm keeping an eye on as we head into the new year. I'll tell you why in just a second. Do a zoom in picture. This is from the end of last week when we finally had enough cloud cover to get out of here. Closer shot of South Dakota, late January, early February. Doesn't typically look like this. I've been here. I know what it's like. You guys get snowstorms, you don't see the ground for quite a long stretch in winter, and we're lacking that snowfall. Now, another thing that snowpack did, stretching from Texas through the Mid-South, Mississippi, states like Louisiana, dealing with ice storm issues, well, it acts like a big reservoir for cold air, much further south than it otherwise would be. Usually you guys are the savings bank of cold air this time of year. Well, when you move it down to Georgia, into the Carolinas, now you're bringing cold air further and further south. So we had satellite images that looked like this, that cold front moving all the way through the Gulf, out into the Atlantic. That very cold air right over the relatively warm sea surface temperatures there around Florida, instantly convex, makes those cloud streets that you can see there just a fascinating satellite imagery of Florida. You might say, boy, I wish I was in Florida this time of year. They're colder than we are this morning in South Dakota. Sunday and Monday morning, 25 Lake Okeechobee, unprecedented. Miami down to 35 degrees Fahrenheit. The Keys were in the mid to upper 30s. Unprecedented temperatures. Tampa down to freezing, Gainesville, Tallahassee, hard freeze galore. I mean, 19 in Central Florida, that's unheard of. The manatees, there we go. The manatees were actually flowing up into the inland areas to try to get some warmth because the Gulf Ocean temperatures fell so quickly and drastically with that cold front. So pictures like this were coming in from the canals around southern Florida. You may have seen on the news, apparently the iguanas, they don't literally freeze to death, but they go dormant. And they were falling out of trees, they were causing issues. I don't know what it's like calling your insurance agent to be like, yeah, I got 3 iguana dents. And folks are rounding them up. You can like warm them up inside and they come back too, they reanimate. I wouldn't recommend that, but it makes for good social media. And so we saw pictures like this Sunday and Monday. Falling iguana alerts. The island of Cuba hit its all-time record low, 32 degrees Fahrenheit exactly. It had never recorded a freezing temperature in the history of meteorological observations. Just this week. That's where the cold air is. That's where the snow has been. It's been off to the south. This is I recommend going to this map. This is poweroutage.com. It lists all the different power outages that are currently in effect around the country using different data. And even early this week, they've since largely been resolved. But almost a week and a half after the storm came through, we still had tens of thousands of people in Mississippi, Tennessee, parts of Louisiana that had yet to get their power back. And their low temps the last week and a half with that snow, like in the teens. This was a big issue. If you follow natural gas prices closely, the energy markets, they react to this as well. Do you guys remember at the end of November how cold we were? The start of winter, the end of fall. Gas prices rallied as a result. Then we had one of the warmest Christmas on record through the middle part of the country. They fell. And we've gone back into this cold stretch. We saw another rally and wild swings in the energy markets. These are dependent on that weather forecast. Another thing that caught my eye this week, quite literally, the sun. The sun has been acting up. It's been throwing these sunspots out. I'm looking at like the top left center, one of the more active sunspot regions we've seen. I think it was 4533. And we watched this rotate around this week, and we're about solar flares with those. Now we've seen them this year. We saw them last year. We saw aurora displays that were visible all through South Dakota, even as far south as Mississippi. My brother-in-law farms down there. He sent me pictures. There's that sunspot region. It's pointed directly at us right now. So any solar flares, or CMEs as we call them, things that make aurora, that can make our electronics go haywire, a little bit worried about those this week. The chances are still low that one's gonna shoot off, but it's higher than it otherwise would be in an almost 10-year period. And the reason for that we're coming off the peak of the solar cycle. So it's an 11-year solar cycle, an increase in sunspot activity, peaked last year in 24 and 25. We're still kind of on the upper end there. We're still seeing that sunspot activity, but we're coming down into that 5-6 year trough without as much sunspot activity. I can assure you, if we don't get that solar flare here this week, I highly doubt we're gonna have a lot more opportunities for auroras until probably 2036 or 2037. It's probably the next time you're gonna see those in the news. Now, the graph on the bottom, I get this question fairly often. I think that takes us the last 10 years, roughly the last solar cycle. The graph up top, we've actually been able to reanalyze data all the way since the 18th century. And you'll see that predictable 11-year cycle of the sun. Now, the difference in total insolation, it's how much energy is actually getting down to Earth from the sun. How much does it change, like peak to valley of the solar cycle? Is it enough to change our weather? It's about 0.01% energy difference. So I'm not going to point at this and ask it to give me really any predictive power with what the season's going to hold in 2026. It matters a tiny, tiny bit. It's not going to shape or break our growing season this year. Another thing you'll often hear, I've heard this before from some other meteorologists, is this thing called Gleisberg cycles. You can actually see a Gleisberg cycle or two on the chart at the top. Those are like 70 to 100 years, undulations, and the peak of that solar cycle maximum within those 11-year cycles themselves. You're still following, I'm impressed. But you can see roughly around 1700, we were way up, and then we spent about 100 years going down and back up. Another one peaked roughly in 1950. Now we're kind of at the bottom end of one of these Gleisberg cycles. Do those impact our weather? Can't find any correlation. I haven't. My colleague Eric Snodgrass and I, we've dove into this trying to figure out if I have something in my back pocket that can tell me where this year's going, I'm gonna be all over it. I haven't found it with solar or Gleisberg cycles. They can predict auroras, when those are gonna happen, electronic issues, not as much weather. Now the sun, the optics, can be useful for other things. One of my favorite parts of traveling the country, I hear all these strange sorts of like weather folklore. I've heard some odd ones, lightning on dead wood. It's like a harbinger of the 90-day fog rule. Has anybody heard of this one? Yeah, a few chuckles. There's all these different ones. There's the common ones, red sky at night, sailor's delight, red sky in the morning, sailor's warnings. You'll often hear a lot of them like maritime. That's the ships. They had a lack of meteorological observations and forecasts. They had to come up with this folklore on their own. This one, and I think a lot of them, even some of the stranger ones, do have a kernel of truth to them. This one certainly does. Red sky at night means the atmosphere has been mixed over by the sun heating up the ground during the day. That causes convection, air currents to rise. Those are what the birds float on. That mixes up the air. And it makes it scatter more light in the evening, making those red colors. So if the sunset's red, that's a relatively normal sunset because the air's been baked all day and mixed around, almost like a boiling pot of water. Now in the morning, when the sun's been gone all night long, the air stratifies, it gets very calm. And that's why in the morning, the sunrise colors are far less, typically, less vibrant. But if they're vibrant in the morning, that means something else is mixing up the atmosphere. Probably a low pressure system, probably a big storm system coming in, probably some rough weather. So this one, the sailors got right. Look around the moon, rain or snow soon. Anyone hear this one before? There's a halo around the moon. You'll see this kind of on cold nights as ice crystals form. You'll see it sometimes in the warm season as well. Well, we often moisten up the upper atmosphere before the lower atmosphere, before storms. So this one actually makes sense as well. Typically when a big storm's coming in, those high clouds will start first in the upper atmosphere, making this halo around the moon. And then 48, 72 hours later, the rest of the storm comes through, and that's when your precipitation occurs. So this one, there's a kernel of truth to this one as well. Macro skies and mare's tails make ships carry low sails. Anytime you see a sky like that, you have what's called warm air advection. That typically occurs out in front of a low pressure system. They're really good at making those clouds. These are pretty good. If you see these, you're probably going to get rain. I'd say within the next 24 to 72 hours. This one is mine. I use this when I'm storm chasing. I've used it in South Dakota and Iowa before. The clouds you see there are very similar to the alto Q you saw on the previous slide, but they're a little bit different. They have vertical development above them. You see those little chutes going up above what those alto Q looked like before? There's a little bit of a difference there. There's like vertical development. That's instability. Thunderstorms like that, that's instability in the mid-levels of the atmosphere. Those clouds are called ACUS, or altocumulus stratus castellanus. We just call them ACUS, and ACUS attacus. You see those, you're probably gonna get thunderstorms later in the day, if not severe thunderstorms. Anybody heard lightning on dead wood? This is a rare one. I've heard this in Kentucky and Ohio before. Now, I've heard if lightning on dead wood, you're gonna have a big storm soon. This one is also pretty true. If you're lightning and storming in the middle of winter, i.e. on dead wood with no leaves on it, you probably have a pretty intense storm coming through, a low pressure system pulling that warm air all the way up, and you probably have a big cold front ready to hit you on the backside of it to bring one of those classic South Dakota blizzards on the backside. We get lightning around here in winter, you got a big storm coming through. 90-day fog rule, I heard some chuckles. 90 days after fog exactly, you're gonna get rainfall. I'll be honest, I've dug into the data on this one and I haven't found it. Not saying it's not true, like I said, a lot of these have a kernel of truth to them. I can't think of a reason why fog 90 days before, at least generally like over a season, might cause rain 90 days later. But it's fun to think about. I know people to this day who still track it on their calendar to try to forecast the rain. In like a lion, out like a lamb, this one, specifically for March, this one just kind of usually works out correctly, but this is how our weather works in winter and spring. Usually the first half is different than the last half of the month. I'll give you an example just from where I'm from, Champaign. If we just look at the temperature chart from Champaign, we started out, where I live, it was actually relatively warm. We had that like Christmas warm up. So we were warm for the first 15 days, but our weather patterns typically last about 7 to 10 days, and then we flip around and do a different pattern. So it came in like a lamb, out like a lion. That's just generally how most months this time of year work out. So kind of easy to say if it comes in like a lion, it'll leave like a lamb, or vice versa. Maybe the king of weather folklore, Punxsutawney Phil over in Pennsylvania earlier this week. If you haven't seen, he saw a shadow. We get 6 more weeks of winter. Today is actually National Weather Person's Day. And unfortunately, Phil is probably the worst meteorologist statistically right now. He's shooting about 30% over the last 10 winters. He wasn't very good before that, but he was at least closer to batting average. And yeah, we don't put too much stake into this. I think it's a lot of fun though. They wear the like top hat and they got the groundhog there. I found out groundhogs are actually very aggressive relative to other rodents. So they're not all as friendly as Phil, but they might be better forecasters. And how is Phil doing in South Dakota? Well, not well. These are our high temperatures today. 50s and 60s, even 70s if you look far west in the Black Hills. A lot of big time early kind of hints of spring this week. Cold still locked in out east where that snow is. But I'm coming back to this map. These are winter departures for snowfall. So as you go west, in those beige colors, we've had less snowfall accumulate this winter. You go east, the Great Lakes, the Midwest, much more snowfall, more on track. But you start going west to Sioux Falls, west of Mitchell, you get some pretty impressive deficits. Black Hills, 20 inches below where they're typically at this time of year. I thought this was kind of a neat map. This is looking at how many days in your climate division since your last blizzard warning. So if you're anywhere from New Mexico, winter storm warning, New Mexico, Texas, through the Midwest, up through New England, Maine, Georgia, South Carolina, you've all had a more recent winter storm warning than western South Dakota. We haven't had a winter storm warning for the Black Hills in over 3 seasons. It just shows you, we usually have these every 2 weeks this time of year. So I went back and looked, does this mean anything for our growing season? So I just did a thought experiment. I went back and looked, I used kind of the last 25 years, all the way back to 2000, and I found every year where South Dakota, Minnesota, North Dakota was well below average on snowfall, trending similar to where we might up this year. Now we still have another kind of month to go. But I said, all right, give me every year, and you can see all the ones I scrutinized all the way back to 1987, 21, 15, 03, 02. All these years we were well below average in the state for snowfall. And I said, okay, in April and June of the following spring, what did the precipitation anomalies look like? And I wanted to see, is there any correlation between that snow drought and future planting season drought? I was surprised, there very much is. If I cherry pick those years, significant deficits in rainfall through spring in eastern South Dakota. Now, most of our snowpack deficits to the west, it's not right over the area we're in now, But there is this background kind of dry concern for the northern plains this spring as a result. What do those following summers look like? Just continue the thought experiment all the way through August. At least precipitation deficit-wise, about 3 inches less. Now, we have another month to go. I have a snowfall forecast I'm going to give you in about 20 slides. I'm not calling for this big drought right yet, but it is something to keep an eye on if we keep those deficits through March. I'm going to show you seasonal forecasts in this a little bit later. It should be important to note. When we put together these like long-range seasonal forecasts, you saw me put together that analog there with the snowpack. We're very much kind of fishing in the dark here. It's a very much inexact science trying to tell you what's going to happen where 6 months from now. And frankly, as much as I love being in South Dakota on Thursday morning in the middle of February, if I knew exactly what the drought monitor was going to look like in August of 2026, if I could paint you all the counties that were in D4 or D5, I would be trading energy or weather derivatives in Cabo. I'd have a pina colada. I mean, I could make a lot of money if I knew exactly where all those insurance policies were to hit, what commodities would be most impacted. All right, but I can tell you where we went in the past with similar presentations. We can look at these seasonal models together knowing that really they don't have a ton of accuracy. Now, one thing they're going to factor in is that snowpack and soil moisture. They're going to look at things like El Nino and La Nina, which I'll explain in a minute. But that's all these models are trying to do. They're fishing in the dark the same way we are. They don't have some magical perspective on where summer's going to go any more than we do just by looking at historical data. Now, we are better in the near term, 7 to 10 days, and the models are very good at this. This goes back, to the early 20th century, and we figured out a lot of the physics behind the atmosphere. If I told you in Mitchell it's 85 degrees on a summer day, in Sioux Falls it's 87 degrees, I know the wind speed between the two, if I can tell you the pressure, radar, satellite, humidity, soil temperature, we know all the equations that govern the atmosphere. I could write you the partial differential equations to forecast the weather out between the two cities. I'm not going to do that. We'll have the computers do that. They're very good at it. They're very efficient. They do it all over the world. And we take their weather forecasts all year long. They look like that. I'm going to show more ahead. And that's been the kind of method we've used at physically calculating the atmosphere, knowing our understanding of it, to forecast the weather. We got really good at this. And the computers, frankly, got really good at this. But it started to change in the last 3 years. I remember this date. It was in the middle of November of 2023. I got a call from a friend of mine, a colleague out of Chicago, said, Matt, did you see the Google paper in Nature that came out today? I said, no. Kind of responded, when a friend kind of sends you a new TV show to watch or like a book or an article, you like want to get to it, but you kind of bookmark it for later. That was kind of what I was trying to do. And he said, no, you really need to read this like right now. Well, Google's DeepMind outfit out of London released this paper in a very, very reputable scientific journal. And they said, well, instead of giving the model all those physical equations, whether between Mitchell, Sioux Falls, or London, or New York, we just gave it all this weather data, and we told the AI model, the neural network backend, to just figure it out and forecast the weather with no physical understanding at all of how the atmosphere works. Just give it to the neural net and see if it can do it. Well, Google did this. The results of their paper were staggering. The AI model beat our very best physical model, the European Center for Medium Range Weather Forecasting. You'll hear us constantly just say the Euro or the ECMWF. Google, by giving it to AI, were able to beat that and release this paper that was very convincing on how to do so. They use something called a neural net. This is the same kind of architecture, the back end of the AI models that power like ChatGPT. You guys played around with this yet? Very, very similar backends between the two. Now, I'm not going to sit here and try to explain exactly how this works, but I'm going to try to give you a rough visualization on this technology that's going to completely upend probably so much of professional work, healthcare, meteorology. I'm going to make that case in a minute. Probably military, frankly, like all technological innovations eventually come to. I mean, this is very significant. What's happening here in these neural networks, which are built to work somewhat similar, analogous to how our brains process information. And I'll give you an example for handwriting. How do we tell this neural net model how to transcribe handwritten numbers into which number they are? Now, to do that, we're going to take the image of the handwritten number there, could be a notepad, and we're going to do something called vectorizing it, which is a very fancy term for, we're going to turn that picture into numbers. Computers like numbers. So how we're going to do that? Well, let's just give every pixel, let's say there's 784 of them, like in this example, all the way across that image. And if the pixel has handwriting on it, that pixel gets a 1, and if it doesn't, it gets a 0. Computers really, really like 1s and 0s. You guys probably know that. We're then going to pass that through all these different nodes, fancy term for, we're going to just change at every little circle that 1 value or that 0 value a little bit by some random function. At the end, it's going to spit out a guess as to what the number is, and it's going to be extremely wrong because all we did is just randomly change those 784 numbers and then spit out a guess at the end by combining them back together. It's going to be wildly incorrect. It's going to think a 7 is a 2, it's going to think an 8 is a 1, and then at the end we're going to tell it how far off it was from the right answer because we give it the training data, we know what each one of these numbers are, or we're supposed to be. We're going to tell it it was off by a little bit, or it was off by a lot of it. And we're going to ask it to go back through the nodes, i.e. looking at the screen reading right to left, and it's going to modify all those random adjustments a little bit to make the model slightly better at forecasting. That phenomenon I just described is called back propagation, just going back and making the model slightly better. It's going to do that billions of times. And by the end of it, it's going to be really good at guessing handwritten numbers because we're going to run it billions of times on little GPUs that NVIDIA sells. And that's why they're making so much money. What's really cool about that back propagation, which is critical to how these work, LLMs, ChatGPT, NVIDIA's stock price, these weather forecasts, is back propagation was first invented by David Rumahart, who's from Mitchell, South Dakota, born and raised here. So there's magic apparently in the Corn Palace that David acquired. I thought that was super cool when I learned that. That back propagation is like lesson 101 if you want to figure out how these neural nets work. So there you go. There's Mitchell's claim to fame with all these AI models. Google's been updating this model since they released it. They released another paper in November, almost to the date, this past year in fall. It's gotten much better. We were able to access these. NOAA very smartly has now their own one. They have a GFS AI model. You may have heard of the GFS model we use all the time. Now they have an AI one that's more accurate. The last winter storm that came through, we started out this talking about it. It got that one faster than any of the other physical models. You can see it there narrowing in on where that winter storm impacted. China, they're not ignoring this. They have their own Pangu weather model. They're putting resources into that. I can tell you, our government employs a lot of meteorologists, not just at the National Weather Service, but in the Air Force, the Marines, and the Navy. I know, I went to school with a lot of them. And they're paid well to forecast. I can tell you those missions that they're going on, that you see in the news, they have meteorologists watching them very closely to make sure those helicopters can fly, the planes can fly, mission critical, getting this weather forecast accurate. And we've been getting pretty good at that over the last 40 years or so. The graph behind me just shows the accuracy of 10-day lag time forecasts, 7, 5, all been getting better over the last 20 years, significantly so. We kind of thought we were reaching a plateau with the physical models I described. I think these AI models are going to allow that graph to keep increasing, improving accuracy, at least in the near term, for these forecasts. At least for weather, it's good. Our weather is getting better, it's getting cheaper, it's getting faster to run. Our hurricane track errors are getting better. You can think of an example from a few years back, Hurricane Otis. We woke up this morning in fall, I believe this was 2023, and we had a tropical storm. I almost overlooked it just off the coast of Mexico this morning when I was doing my forecasting. It was a weak tropical storm. The forecast from the National Hurricane Center, along with a lot of other folks, predicted that it would remain a weak tropical storm, make landfall somewhere in remote West Mexico. Not really a concern. We were just keeping an eye on it because it had a name finally. That was in the morning. By noon, 6 hours later, we had a major hurricane. It had strengthened from a weak tropical storm and 6 hours after breakfast to a major hurricane. 6 hours after that, came a Category 5 strongest storm in the Pacific that year and devastated Acapulco. That morning, we had no idea. No idea. Strongest storm of the season, and that morning we had no clue. Every model had it staying tropical storm strength or weaker. Huge forecasting bust. Well, part of the reason is these physical models that we run, the current ECMWF, we plug our data in, like I said, from Mitchell, from everywhere, and then we give it to the model. It has to run that physical calculation for 7 hours before we get the forecast back. So we have to sit there on our hands and wait until 1 p.m. to get the morning forecast model. We're waiting right now for that next model. I want to see if it's going to snow here next week. The Google model and that paper in 2023, the most landmark part of their paper, it was a little tiny paragraph at the bottom of the paper. I thought it should have been right in the top of the abstract. Their model, it's better than the ECMWF. It runs in under 1 minute once it has the new data. It's a sea change. I just threw this in there because I always get asked, Matt, what would happen if one of these bigger tornadoes hit a windmill? Here's your answer. There's one on the left there that's going to be impacted directly by an EF4. Lost the blades there in the last frame. And that was destroyed. It actually caught on fire after this. This was an EF4 east of here, Greenfield, Iowa, 2 years ago. This is storm chaser Stas Bronsky, very good at what he does, but we have a saying in the storm chasing community, if the tornado visually is not moving to your left or your right, and it's getting bigger, you got big problems. So, all right, let's use the rule here. Is it moving to the left or right? Nope. Is it getting bigger? Yep. And that's why you saw Stas make the very good decision at the end to get the heck out of there. Stas has a French bulldog named Manny. Manny's one of those dogs with like his own Instagram page. If you guys know what I'm talking about. And Manny in this entire video, I don't have the sound plugged in here, but Manny is snoring that whole video. Dead asleep in the back seat. A little bit closer to home, this was Watertown, South Dakota last July. At the end of July, EF3 tornado near one of the lakes over there on the east side. I don't think these storm chasers would be offended if I said this is insane. Being that close, you'll look closely in the Ford Escape. I think that is, somebody's gonna get out of their car. Getting really good footage. Luckily, it's largely stationary, but you gotta be, I mean, this goes without saying, you gotta be careful around these things. If you look off to the right of the base of the tornado, do you see that little like mist screaming into the backside of it? We call that in storm chasing the ghost train, because the winds in that mist can be 80% of the tornado's strength. Let me tell you, the tornado's obviously very strong wind speeds, but that's 160 mile an hour tornado. So 80% of that, you're talking 120 mile an hour winds in that ghost train. That's why we call it the ghost train. And you saw what it did to that outbuilding well outside the vortex. This was a little bit west. This was north here. I want to say Elkhorn, if that sounds familiar. I believe this was the next day, July 28th. The fact I'm showing you tornado footage from South Dakota at the end of July tells me a lot how the year went. If you got moisture, if you have flow to get severe weather up through here through the end of the year, I can tell you, despite the areas actually hit by the severe weather, you probably had a pretty good year for growing crops if you had that much moisture late in the season. There's July 28th. That tornado occurred early in this visible satellite loop, and right in the south central part. And then it formed a derecho, went screaming through Sioux Falls later that evening, through Iowa, this flattened cornfields in northern Iowa, portions of southeast Minnesota, and made it almost all the way to where I live in central Illinois. Petered out right at the end. For all the talk about tornadoes and the videos, hail, which you guys are very familiar with out here, derechos are probably my biggest concern. We saw that, I think, in May of 22 or 23, especially with irrigation pivots getting knocked down. I mean, derechos can just flatten a county worth of crop. A hail might hit you here and there. There'll be hail swaths that are a little bit narrow. Tornadoes obviously very narrow relative to these storms. These derechos can affect, like 2020 saw, our end of year national carryout because of the damage in Iowa in August of 2020. We hit another milestone, surprisingly, in North Dakota this year. One of my favorite droughts we've ever had in the United States, we were in the midst of for the last 13 years. We were in an EF5 tornado drought. We had not recorded an EF5 tornado anywhere in the US for 13 years. It was a pretty good drought to have. In June, I think it was June 20th of 2025, an EF3 tornado was recorded near Enderlin, North Dakota, north of here. EF3, it spent 2 months as an EF3 recorded until somebody got drone footage of this train that was derailed by the tornado, sent it into the National Weather Service. You might want to have a look at this. They looked at it and sent it to some engineers, and they saw that tanker sitting up there a quarter mile. And you want to know what caught their eye? Obviously the derailed train, the axle still ripped off sitting there by the railroad tracks. All of that's very impressive. But if you look closely at that tanker sitting at the top of the screen, there are no track marks in the field. The tornado tossed that tanker a quarter mile. Those tankers are a federally regulated polygon in shape, very easy to calculate. The wind speeds required to throw that thing that far. 215 mile an hour winds are required. And we ended our EF5 drought. They upgraded that storm retroactively to an EF5 because of that tanker. 215 mile an hour winds, Fortunately, this was a fatal tornado. We have ring footage of the supercell at night, just completely ominous. Nighttime tornadoes scare the crap out of me. And there went the drought, EF5 in North Dakota. Hurricane-wise in 2025, we technically had a busy kind of banner year, but they're all east, avoiding the US. We had no hurricanes make landfall in the US. Tropical Storm Chantal is the one that went through the Carolinas there. But we did have 2 Category 5s, which are fairly rare. Unfortunately for Jamaica, Hurricane Melissa hit there, one of the strongest storms in Atlantic history, probably number 2 or number 3. Hurricane hunters flying through that. They're a joint effort between the Air Force and meteorologists from the National Weather Service that fly in those planes. Very brave, taking those measurements from the middle of these storms, and this awesome time-lapse footage. It's just incredible. Those clouds from the base of the ocean, about 1,000 feet ceiling level, up to 50,000 feet above. That's how big that cloud stadium is. And the only way out of the eye is back through the most turbulent part of the storm, the eye wall. Satellite footage from above. These storms run, their fuel is that warm ocean water. So if you steal that warm ocean water, you replace it with land, even just the small island Jamaica, it's like taking the fuel out of the engine of a car. Just completely loses its strength. One reason we saw a busy hurricane season, albeit not a lot of landfalls, we were in a La Nina last fall. We're actually in a La Nina still right now, although barely, in 2026. All you'll hear when we get a big El Nino is the news talking about El Nino, La Nina, and you're like, what is that though? And they always show a picture of a palm tree swaying in the wind with rain, as if that summarizes it. All La Nina is, for our intents and purposes, is cool water in the central tropical Pacific. So I just boxed it in the pink box. That water is cooler than normal relative to that location, or in a La Nina. If it's warmer than normal, if it was orange and red on this map, like it was in early February, it would be in an El Nino. Now, why does that water matter for our weather in South Dakota? Well, it turns out if you affect ocean temperatures in the central tropical Pacific, you affect where hurricanes are going to occur. We saw that in the Atlantic last year. You're going to move convection around, clouds, storms. And that all works together to impact our jet stream. In winter, it's fairly predictable. It usually does something like this when we have a La Nina. It's very wavy or amplified off the coast of the US. We see a big ridge across California or Washington that dives down right through South Dakota into the southeast, bringing low pressure systems and clippers along it. We usually see more snow in the Midwest like we've seen this year, more inclement weather in the southeast, but underneath that ridge near the western plains, you can get stuck in some drought conditions. We also focus on it in summer. There's correlations that we look at in summer as well. In July, August, and September, if we have an El Nino, we tend to see maps that look like the above, at least since 1979. Wetter on the left chart for precipitation is counterintuitively in red. Well, we're wet right through the kind of Four Corners region, right through the northern plains, even into the Midwest. That's why we typically root for an El Nino going into a new growing season. Temperature-wise on the right, we tend to be a little bit cooler. If we're wet, we're a little bit cooler at the peak of summer, probably gonna go a pretty good crop, all else equal. Now, the values on the color bar are correlation values. And unfortunately, for predictive purposes, at least over South Dakota, you're talking like 0.2, 0.3 at best. That's like the confidence the Patriots are going to beat the Seahawks in the Super Bowl. It's kind of a toss-up right now. I think it's leaning toward the Seahawks. They've been playing so well. But we both know anybody can win that game. And unfortunately, 2026 is still sitting in that boat for me, despite El Nino kind of rearing its head here. We'll talk about that in a second. That's Tahiti. That's right in the central tropical Pacific. Their waters are colder than normal. If you dive off Tora Tora there, or Bora Bora, what we want to do is we want to raise those ocean temperatures, improve our chance of having a pretty good year. Right now, this past winter, what have we seen? Have we been in that textbook La Nina flow pattern that I described earlier? Well, yeah, we've had big ridging across the western US, troughing across the Hudson Bay, plenty of Great Lakes snowfall. This La Nina has behaved pretty textbook up through this point in early February. In fact, right now, the jet stream flowing over our heads looks like this. Just grabbed that this morning. Big ridge over California, diving down into trough southeast, jet stream flowing right above our heads here in South Dakota. If we look over in the central tropical Pacific, earlier in November, I took this loop. back at the end of fall. We had trade winds flowing nice east to west, right across the central Pacific. What we typically see in La Nina years that helps keep those water cooler there. But lately, those trade winds have started to back up in the western Pacific. We've seen these, what we call westerly wind bursts, a disruption in those trade winds over the Pacific. These tend to occur early in El Nino years before El Nino develops. In fact, these help El Nino to develop. So whenever we see these westerly wind bursts, I start thinking about that El Nino potential in the following year. And as a result, La Nina is when we're down on those ocean temperatures in that box. Those are measured here on this graph since fall. We've been slowly rising those ocean temperatures to the point now the Climate Prediction Center, their latest forecast, June, July, August, September, better chance than not that we'll develop into an El Nino. Not a home run, we're talking 60%. What's the latest forecast from the ECMWF? I mentioned I'd show their seasonal models. Where are those ocean temperatures going in the Central Pacific? By July, we're in an El Nino, at least according to the ECMWF. If I'm trying to predict what the growing season is going to look like here, I actually don't look that closely at them. I'll be honest, 0.2, 0.3 correlation, I don't make any money sports betting. And that's, that's correlation that you're working with in that situation. Where I'm looking at is in the Northeast Pacific, south of Alaska, west of Canada. If I can keep those ocean temperatures warmer, much better correlation with adequate rainfall or more rainfall on the ground I'm standing at right now. And at least from the ECMWF forecast, that's a friendly forecast for rainfall. Their latest seasonal forecast just came out for this summer. Again, I don't put too much stake into those, but because they're keeping those ocean temperatures warm, I knew it would be wet, and it was. There's their forecast for El Nino, likely to develop by June, at least according to the ECMWF model. As far as the drought monitor is concerned, right now at the end of January, early February, technically moderately dry in the southeastern corner, southern portion of the state, kind of right near where we're at here. I'll be honest, I don't look at the drought monitor when it comes out too aggressively. I usually go, if anything, to the USDA drought monitor website. At the top, there's a little drop-down tab called Maps. Hover over it, it'll list something called Change Maps. I click on Change Maps. I do the 10-week, 12-week, sometimes the 8-week change in that drought monitor classification. I think there's more of a story on this map than the base map. Where's the trend? The trend is your friend. Well, the trend shows not a great direction in the western plains, Nebraska, high plains of Wyoming, Colorado, sneaking into the Black Hills, the lack of snowpack there. So you can see that story developing west of here, more so than just glancing at this map. You can see the Midwest doing a little bit better because of that snowpack that's melting now at these warm temps. You go further west, we're having a snow drought in the western US. This is a source region for the Missouri. Montana, actually, of any location over in the west, particularly western Montana, they're doing a little bit better, a little bit closer to average, but still, by and large, the western US down on snowpack this year. I'm getting a lot of complaints at ski resorts. They're complaining, woe is them. They need that snowfall, though. They make all their money in like 4 weeks. And they've had no snow during it. Been a big problem out west. It's also a big problem, frankly, for the Colorado River. One like big political issue, and this isn't like directionally political, it just is undoubtedly would be a significant issue. The Colorado River ends right here, snakes right up through this. If we keep adding down years on the Colorado River, it gets back to levels where it was in the early 2020s. A lot of people don't know this. There was a really kind of shaky situation. The Biden administration kind of forced this agreement between California, Arizona, Nevada to figure out what they were going to do with the Colorado as that water just shrank. I mean, they were finding stuff at the bottom of Lake Mead they hadn't seen in 50 years. That water, I mean, depends, a lot of population depends. You see which cities are growing, it's like Phoenix. You start losing the Colorado River again, that's becoming a bad situation. Seasonal forecast from the Climate Prediction Center. This is just their April through June precipitation forecast, more so focused on the Northwest. They don't have a lot of information in this right now. Warmer for the Southwest where we've seen a lack of snowpack. I went back through all the years, you'll see me do this a lot, just to get a benchmark. I went through every year since 1980 where we started in a weak La Nina. We just saw we're in that now. Those water temperatures are cooler than average in the Central Pacific, but they're not crazy cold. I took every year we started in a weak La Nina and then made that El Nino at some point in the following year, like the predictions right now are leading toward. And I said, all right, of those years, give me the spring precipitation departures, above or below average, and then bin them by climate division. When I did that, you can see all the years I cherry picked, 23, 18, 14, 09, 06, 02, etc. And in spring, I came up with a pretty good dry signal in the Central Plains. even into portions of the Midwest, even into the southeast portion of the state that we're in. Something of a signal there. Not wild, but definitely leaning in that direction, certainly in Kansas or Oklahoma. Reminds me a bit of 25, when we saw a lot of drought down on the southern plains. We saw pictures that looked like this, dust storms moving up through Texas. This was southwest Kansas. I mean, it was dust storm after dust storm in spring of 25. Would not shock me if we see more of this drought rematerialize, and we see more of these dust storms as these big lows wrap up to our south. This was from West Texas, Morton, Texas. I believe this was an EF2. There's no other technical description. That's just a big, dusty tornado. What happened in those following summers? Well, actually fairly friendly on average growing seasons. Technically below average, but you're talking anywhere between here, Missouri, Iowa, you're looking at 8 to 10 inches of rainfall in summer. That yellow number is about ½ an inch below average. I can grow a pretty good crop just about anywhere with ½ an inch below average if I move it around correctly, depending on when it falls. So I'm not too concerned about that. Maybe more Louisiana or Mississippi. Temperature-wise in those years that I cherry-picked above, fairly friendly, not if you're in Washington. And as much as I say all this, kind of trying to figure out where we're going, if I was standing in this room in 2025, which I was in Sioux Falls when I got snowed in, our concern for the 2025 growing season was drought. We were concerned because our soil moistures across the middle part of the country look like this, huge deficits. I mean, from Bismarck all the way down through East Texas, all the way over to Ohio. The Mississippi River reached low stage again in the fall of 24 before this. All of our analog thought experiments that we went through, and we just went through some together, they all pulled up all these dry years and heat over South Dakota in the summer. This was a concern in 2025. I mean, look at all these little thought experiments we did. The forecast models, this is the NMME, the National Multi-Model Ensemble, big time heat and drought concerns over the middle part of the country in summer on these models that we ran in February 2025. What happened in 2025 in summer? We set record rainfall values in Iowa and eastern Nebraska. Wet in South Dakota, wet in Minnesota. We had orange dust blowing through the fields. It wasn't sand, it was fungal spores. I mean, we were too wet, if anything. There's southern rust, made its way almost all the way up into Canada. They actually did record spores as far north as Alberta. Pictures that look like this out of Iowa. I'm told it wasn't quite as bad here. We dug through the data. I pulled up Ames, Iowa, kind of near where we saw some of these videos, trying to find the smoking gun. Where did all this southern rust come from? Well, obviously the spores came from like Mexico where they overwinter, but where did the actual stress and yield robbing disease come from? Well, we pulled up leaf wetness for 2025. That's in that black dotted line. In the last 10 years of leaf wetness, accrued leaf wetness, or in all those other colors that you can see there, by the middle or early part of July in 2025 in western Iowa, we were running about average for accumulated leaf wetness last year, maybe a little bit on the higher end of the average envelope. In 2 or 3 weeks, we went to the highest ever, at least to the highest over the last 10 years. That's a 2-week very wet period, waking up with a lot of dew on the crops, baking it overnight, a lot of heat, a lot of moisture, a lot of fungal pressure thereafter. What we're trying to do this year is build a model to forecast this, because we can forecast leaf wetness. And so what I'm trying to do is not get this right retroactively, but send off that alarm bell 2 weeks before, and we know that leaf wetness is going to spike in a 2-week period. We're going to try to add that to the website, and I'll show you at the end of this. Another problem here, just with fungal pressure in general, our overnight minimum temperatures have been going up. This can stress the corn crop anyway. It also increases that fungal kind of happy zone where it starts to reproduce more quickly. And so just naturally across this area, especially toward the east, we've been seeing rising fungal pressures. I went back through the suite of years that I cherry-picked earlier where we started in a weak La Nina, and I did something you're not supposed to do. I cherry-picked it for drought. And I said, I want to see every year that ended up really bad right here. Not really bad, but enough to show up on a negative yield deficit relative to the national trend. I pulled up 23, where just-in-time rains saved some of the crop, 06, 02, and 91. I wanted to pull up the bad years, figure out what was happening in those years, and see if we can compare it to where we're at this year in 2026. Well, in January of those years, we had a weak La Nina. That makes sense. These were all weak La Nina years. We also saw a little bit of cold water off the Alaska coastline, off the British Columbia coastline, west of Washington, the state. By April, That La Nina had faded, that makes sense. All these years I cherry picked, started in a weak La Nina and warmed up to an El Nino eventually. It makes sense that the cool water signature in the Central Pacific has faded some by April in these big drought years. But what's not fading is that cool signature west of North America. It amplified. You got much colder water now developing in the Gulf of Alaska, off California, all the way to Hawaii. We call that the Pacific Meridional Mode. We love our acronyms. It just means cold water off the West Coast. When we get that, that is an alarm bell for drought. If I see that in April of 2026, my tone's going to change very quickly. Well, in 2025, what happened? Well, you see that kind of cold water signature a little bit west of Cabo, stretching toward the Central Pacific. There's that weakening La Nina. What happened thereafter? That's always the concern. We get a big drought with a big ridge. Well, by August, we were baking south of Alaska, west of British Columbia. What does that do to the jet stream in summer? Well, it just launches it up and over through Alaska, dives right down through South Dakota and Iowa in summer. There's your northwest flow thunderstorms. There's your tornado videos. There's your southern rust. If those water temperatures stay warm, I'm not going to be as worried about the crop. If anything, too much moisture. Here we are in 2026. Those ocean temperatures south of Alaska, west of North America, they're playing along up through February. Not seeing a big change in the cold direction as of yet. Things can change by April, but at least right now, no big concern. I was looking for a good comparison where we're at in 2026, maybe an analog. Honestly, the closest one I could find over the last 20 years was 2014, surprisingly. 2014 also had a weak La Nina. 2014 also had quite a bit of warmth in the North Pacific. Some differences there over by Australia that you can find, but by and large, these are pretty similar years, at least in February. Now, 2014, it had that Central Plains drought concern that we've talked about all the way up here through South Dakota, a little bit on the cooler side as well, March through May. But the summer, if anyone remembers 2014, bumper crop, if anything, too much moisture in parts of West Iowa, not a lot of heat concern. We grew a great crop across a wide area, just about every major growing region save for the cotton or citrus belt. Now, looking at those same seasonal forecasts, which, disclaimer, did so bad in 2025, let's at least look at them. In spring, they agree with that analog thought experiment we did, that drought concern in the Central Plains for spring, not necessarily bad for planting. We'll need some moisture to get in here, right, to get those rows to close. But technically, enemy on the left's wetter for South Dakota, but drier further south. Latest ECMWF forecast, this just came out this morning. I was able to sneak it into my talk before I got up here. Spring, not as much drought concern over the Central Plains from the European model for March, April, May on the left. On the right's the latest June, July, August. Now, we can't put a Sharpie in a seasonal forecast 6 months from now. The accuracy on these are not good. But I know why the ECMWF is wet. It's because it has those water temperatures warm in the Northeast Pacific. It's developing those in the direction that I want to see, at least for now in February. Again, if I knew exactly it was going to play out that like the map says on the right, there's a lot of different financial products I could be trading very confidently right now, and I'm not doing that because no one really knows until we see where things develop from here. What I do have a pretty good handle on is the next 10 days. We still have that northwest flow that I talked about earlier, but we're slowly turning that around, getting some better flow out of the southwest. Taking this forecast for the weekend, you don't see much over the plains, but next week, get a low over Colorado, leaves from the ECMWF spins up into some snow. That'd be measurable snow across South Dakota in the latter part of next week, maybe Wednesday, Thursday. Let that play again. See some activity move through the northwest this weekend. You'll see a low sneak down California. As that happens, that low develops in Colorado. We call that Lee cyclogenesis. And snowfall for much of the state of South Dakota. Now that's near the end of next week. That's a 7 to 8 day forecast. I can't put a Sharpie on that either, but I think we'll get a low through this area with at least a decent chance right now of snowfall. I looked at the latest model runs. You saw me on my phone right before this, trying to see what the early ones said this morning. They're kind of bouncing around. The GFS is less bullish for South Dakota snow. The ECMWF, they're your buddy right now. If you want snowfall in this area, I want snowfall here just for the soil moisture later. And it's been kind of sticking with that snowfall right now next week. We tend to lean to the ECMWF. It performs a little bit better than the GFS. If you just look at this in terms of raw precipitation departures, wet across the east, wet for the northwest, and that swath through the Midwest, through South Dakota. High temperatures Monday, more of the same. Sticking to a warmer side as that ridge comes over the Continental Divide. It's less out west now, more so over the Central Plains. We're going to stay on the warm side. Obviously shifting back colder late next week with that snowfall. But generally the long range forecast getting wetter for the northern plains, the upper Midwest. Even wetter a bit for the west. I think this is good news. This takes us February 13th through the 19th. I think there'll be chances in there for snowfall for the ground we're on right now. You can see this from the Climate Prediction Center out of College Park, Maryland. Warmer through mid-February. Better chances for precipitation, likely still on the freezing side for snowpack in this area. Long-range forecasts don't have as much of that drought concern across the western plains, more so off to the south, the southern plains. This takes us all the way through March 15th. Seeing some of that southern plains drought concerns creep up though. If I see it develop there, it's not unlikely that later in spring it moves into Kansas. Another thing I'm keeping an eye on, this is the stratospheric polar vortex. So this is literally the polar vortex you'll hear about on the news. We're looking up at the stratosphere, so 10 millibars, way, way above where the planes fly. And right now, at the start of that loop, let me just replay it. That's the start of the loop. The polar vortex is a bit elongated, but largely intact, kind of stretching from Siberia through like Baffin Island, northern Canada, but it's intact. It's just a bit stretched out. Well, I'm gonna play the forecast forward of that. Watch that blue circle there. That's that vortex over the stratosphere. It's gonna split in two late next week. A piece of it's gonna come over the US, actually over our heads, and another piece is gonna go rambling around near Europe. When that happens, it can increase the chance of a cold air outbreak occurring roughly 1 to 2 weeks later. So that would put a late February, early March, big cold Arctic air outbreak back on the calendar. I'm keeping an eye on that. So warm here over the next 10 to 15 days. Better chance for precipitation over the next 10 to 15 days. Would not shock me. You know this all too well in South Dakota if winter comes rearing back in early March for one last big show. We actually measure the strength of this polar vortex. We measure it throughout winter. That's in red for 25, 26. Last year is in blue. We can see in October and November, that polar vortex weakened considerably because it got split in two in November. And we had that huge cold air outbreak right at the beginning of winter. Then it re-strengthened and it kept all that warm air up near the poles. We had the crazy warm Christmas and it's kind of oscillated since then. We've had some cold air obviously come through, not as much snowfall. The forecast is in orange, big weakening occurring again. Wouldn't shock me near the end of February we go back over. I wanted to see if I'll still have a job after AI. So I took the 500 millibar height forecast. I showed you one of these earlier. I gave it to ChatGPT. It's worth mentioning, I do pay for like the cheap pro version. And I said, all right, here's the 500 millibar forecast GIF. I just showed one of these earlier. Can you tell me roughly what's gonna happen? Just look at the forecast image that I put in there over the next 7 days and the week after that and discuss any major pattern changes. And then I just recorded this live. This was last night, by the way, in my hotel room. All right, I'm reading it. Strong meridional flow, amplified, impacts broadly, west coast, cooler, unsettled, eastern US, sticking cool, but then turning warmer, southeast, mixed signals. Okay, next week, flow actually gets more progressive. Ridge expands to the central US, but starts to weaken in week 2, blah, blah, blah. Key takeaways and the pattern evolution. I read through all of this. It's like 80 to 90% right. Kind of scary. Kind of scary. There's a few nitpicky things in here. If this was like a student, I'd give them like a B-. That's a little scary. Because next year, is it going to be like a B+? Next year, is it going to take Matt's job? We'll find out. Find out together. The point I'm trying to make here is I can do that in like 10 seconds. And this stuff's powerful. David Ruhlmahart, good job. Looking down at South America, there's been some mixed signals in South America. If you actually look at satellite soil moisture estimates, those are the same that kind of concerned us in early 2025 over North America. If you were to look at them over Brazil right now and Argentina, it actually shows quite a bit of quote unquote drought, at least from satellite. But the satellites perform questionably in those areas. We just don't have the same data that we do in South America that we have here. But if you look at the NDVI from Brazil, this year compared to the last 10 years, it's the highest it's ever been in the middle of their summer, right? It's the boreal winter. It's the austral summer. I think I got that right. So that tells me those estimates right now for record production down there are probably correct. For soybeans, they're harvesting those quickly right now, putting the second safrinha crop in for corn. If we look at Argentina combined with Uruguay, well, closer to average. More of the drought, actual droughts being felt in Argentina and some of the growing regions, far southern Brazil, Uruguay. But even there, the NDVIs aren't well negative. They're somewhere around average. Actually trending above where they were last year. Look at that soybean harvest progress. This is from last week, so I'm sure they've been working over the last 5 days. way above schedule on the soybean harvest. I mean, sometimes we root for them to be delayed. That means the second crop gets in later. You kind of shorten their season. That's already a short second crop season. That can cause some issues with them just logistically. But right now, that crop's coming right out of the ground for soybeans, expected to be record production there. They just had enough rainfall this year. And they're even shifting a little bit drier right now in the middle of their harvest. Sometimes you can kind of shift too wet, too late, and it impacts their harvest. Unfortunately, it's working out pretty well for them. Second crop corn's going in pretty well. It's gotten a little bit delayed here over the last 10 days, but still well within that kind of average envelope. Not seeing any big kind of logistic disruptions here. If you're looking for a big weather market right now in Brazil, it's just kind of a little bit few and far between. The only thing I will say over the next kind of 10 days, still seeing some of that southern Brazil, Uruguay drought, far northern Argentina. It's just such a small area. This would be like, it's the middle of July. We're having a great year across South Dakota, Iowa, Illinois, and like Ohio was in drought. You'd be like, well, that stinks for them, but we're gonna have a good carryout, we're gonna have a big crop. It's just not a big enough area to affect their production. Their production occurs in like Mato Grosso, Minas Gerais, Mato Grosso do Sul. All these names I'm saying are right up in here. That's their I states. They've been wet, they're growing a great crop. If I take this forecast well out through mid-February like I just did for South Dakota, I can find some dry signal kind of sticking in there. But I think this is just gonna allow them to get the last of that soybean crop out and put in the second crop for corn. And if anything, Argentina, now Uruguay, and southern Brazil, they're going over wetter in the long range forecast. To get some moisture in there. It might delay some of their second crop a little bit there, but I'm just struggling to find an inclement weather story there. What we are seeing into their late summer, maybe early fall, is that dry concern through Argentina, far southern Brazil, Uruguay is maybe sticking around. Again, even if that area goes into some drought, it's not really enough to impact or offset what's likely to be significant production from central southern Brazil. If you guys want to follow along with the story, a lot of the maps that you saw here today, a lot of the discussion, we produce a YouTube video every single morning. I did it in my hotel room a few hours ago. And we upload it to YouTube every workday. So you can just go to Nutrien on YouTube. If you search that, you'll find our page very easily. We put a presentation together every morning that looks similar to the one I just did here, focusing on national weather, usually honestly focused on the prime growing region, which we're sitting in now. We also upload a lot of this discussion to this website, agweather.com, which I invite you to check out. We have a Facebook feed there you're welcome to follow. And just a fun place to find a lot of these maps we put together. Eric and I, when we kind of started doing a lot of these presentations, my colleague Eric Snodgrass, we needed a coherent place to put all the same maps that we were looking at so we could compare our notes one-to-one. So we put together this website. We threw up a lot of these forecasts together. And it was really just like a sea of maps for folks who followed it for a few years now. And we found out that you guys love looking at the GFS, the ECMWF. We have the AIFS on here. I just added GFS AI the last week. It's been a lot of fun doing that, so that's on here now. You're gonna see that probably released over the next month when we pressure test that one, make sure it's good to go. And we found people love it, so we tried to clean it up a little bit. You can get local weather out of this. In fact, the leaf wetness data I pulled up from last year was out of this website. It's just been a lot of fun to put together, so I invite you to check that out. That's it, that's 108 weather slides at 10 a.m. Congratulations, you guys got through it. I'll open up to questions. Anything you guys wanna know? Ask about sunspots all the way to floods or where we're going in 26. Be happy to talk.
Question for you.
Yep.
What's your thoughts on, they actually predict that we're going to see more of these derechos, these high wind events through our region here. Does that correlate with what you think?
Yep, so believe it or not, I'm going to run from here at 11:30. I'm going to use your guys' 80-mile-an-hour speed limits, which I really appreciate, and try to get to Southern California to talk to a group on crop insurance tomorrow. We'll see if that works out with flights. I put together that exact graph for them. I wish I could show it to you right now. I didn't put in this chart because it's less, long-term trends for hail reports and things like that. But if I could show you it, it's up the last 20 years. Statistically significant recorded wind events in South Dakota, stretching all the way through Ohio, are up over the last 20 years. Now, some of that is what we call report inflation. So there's more people. The Eisenhower interstate system in the 50s, there's more cars, there's more smartphones, where now if hail occurs, you just go, and there's the report. Before you had to submit an official report. So some of that is probably report inflation, but we're starting to think some of it's meteorological as well, that there might be more of these derecho threats. I think part of that is derecho wasn't a term until 2008 and really didn't start being used colloquially till the last 10 years. The news now says it all the time. So people are like, wow, these new derechos only happen now. They've been happening for millennia in the central part of the country. Bison 2,000 years ago were getting hit with 70-mile-an-hour wind events and probably did just fine. But we're seeing a little bit of an increase in that wind report. And I'm guessing they'll probably stick around the next 20 years. So if you felt kind of an increase in derecho frequency over the last few years, that might be kind of the new benchmark. Other questions? What do you guys got? Anything you want to know?
Must have some more questions. Ask him some hard ones.
Yeah.
How many days out can you, with some credibility, predict the weather? Like 3 weeks out?
Yeah, good question. So how many days out can we, with some reliability, to predict the weather? It's a good question. There's kind of a nuanced answer, as you'd imagine. If I'm here's a good example. I get asked quite frequently to forecast weddings. And so I inevitably will look at my email in the morning, and this always happens. I get an email, usually from a loving dad. My daughter's getting married. Let's say I get one this morning. It's usually this is how it works. It'll be February 5th, and I'll get a morning, hey Matt, saw you last year in Kentucky. My daughter's getting married in the end of March. Can we have it outside or not? The venue needs to know next week. And I'm like, this guy's he's trying to get it outside. He wants his daughter to have a perfect wedding, or don't have a wedding in March if you want her to have a perfect outdoor wedding. But there's really nothing I can do for you until because that's a very specific forecast. You need to know in a roughly 1 hour window, maybe 5 if you want the whole thing to be outside. You want to know in a 1 hour window, is it going to rain on a specific day? That forecast in summer is real hard because you get pop-up thunderstorms all the time, even over here in South Dakota. If I want to forecast a wedding, give me like 5 days in advance. I can start working with you, maybe 7. If you live on the West Coast, their weather's a lot more like long range, so I could probably do 7 to 14 days there. But if it's South Dakota in July, give me like 3 to 5 days, and I can give you that kind of afternoon forecast somewhat reliably. 2 days before the event, we're pretty sure it's going to be outside or inside. There's always a 10% chance you just get a crappy thunderstorm that blows up. So if I really want to forecast something narrow, it's got to be close, like 3 to 5 days. 7 days out, I can give you a storm's going to be coming through. For example, next Thursday, this time, there's a decent chance you guys have snow falling. Decent chance. I wouldn't bet the house on it. So I know a low pressure system is almost very likely to form in Colorado and race through the eastern part of the country next week at the end of the week. But is it going to race through Missouri and Illinois, or is it going to race through Iowa and Wisconsin? That's going to move that snow corridor south or north. Maybe north of here, maybe even further south, you guys get more in that snow band. So 7 days out, I know that low is coming through. I know the central U.S. is generally going to be stormy and wetter, snowy if you're on the northern side of it. But I can't tell you exactly where that snow is going to fall. I can't tell you exactly how much rain is going to fall 7 days out, but I know something's coming. 2 weeks out, I can tell you if it's going to be generally colder or warmer relative to average. We just kind of walked through that, the way the jet stream's swinging around, but I couldn't give you like that afternoon's going to be wet. And I couldn't give you you're going to get 4 inches 2 weeks from now. But I can tell you it's probably going to be trending warmer and trending wetter in that 2 week period. That's 7 to 14 days. After that, it gets real wishy-washy. The only thing we really have to look at is what I showed you earlier, the stratospheric polar vortex. That starts to weaken. There's some statistically verifiable cold air outbreak potential. 3 to 4 weeks later, you're getting real wishy-washy. Seasonally, it's crap. So that's the disclaimer I have to give you. I can't stand up here and tell you what's going to happen in South Dakota in June. I can tell you what happened in 2014 and 18 and how similar we are to those years. But again, if anyone knew reliably, they wouldn't be telling you, right? They'd be at a trading desk somewhere keeping it to themselves. Does that answer it okay? Yeah.
How close do you watch Kokora?
How close do I watch what?
Kokora.
Oh, Kokoras. I love Kokoras. Yeah, so that is I don't remember the full acronym right now. It's like 7 letters, Kokoras. It is a community rain measurement. They have a whole website. You can sign up, you get a rain bin. You have to stick with it, do it every morning. You got to make sure it's in a regulated position near your house, so far away from a roof or any of that. I look at that all the time to try to figure out where the recent rain fell. So strong appreciator of the people getting up and recording all that. And we use that in a lot of our weather models. So that's a part of the data we plug into those models to make them better from Kokoras. It's a great website. Yep.
Quick question, not too relevant, but you would talk about sunspots and the cycles. And how do you get that information from like 100 years ago? I mean, how do they measure that?
Yeah, I'm not the best to answer that. I think it's probably from tree rings and ice. It's probably my guess. They're taking tree ring data, which can, I think, accounts for carbon and some other isotopes that might be relevant. But I think they're getting it in and out of ice cores. And so the measurements that you saw up there from like the 18th and 19th century, I don't think those are like direct radiation measurements, but they might be. I mean, London had some pretty advanced stuff back then, obviously the telegraph shortly thereafter. So I think they're probably looking at like trying to reconfigure what the value was as a proxy based on some of those more hard data. That's a great question. I don't know exactly.
But as far as its effects are only a few percent one way or the other.
Yeah, about 0.1% of the total irradiation. So enough to change the temperatures by maybe 0.1%. It's not nothing, but in terms of how it feels outside or what the weather pattern looks like, it's almost, I say the word almost because it's science, almost non-significant.
You mentioned carbon in your last question. What do you, same answer, what do you think about the carbon we are dealing with today on the farm? Is it something that's a factor that's going to hurt us or help?
So the question is about carbon. What do I think about that? And what I think about it at the farm. So you talk about carbon, are you talking about carbon dioxide and climate change, or like, you don't mean like actual carbon on the farm? Climate change and carbon, that kind of sums it up. Yeah, that's a good question. Yeah, so I'll give you my spiel on climate change. Okay. What is carbon dioxide? It is a very, very small percent of our atmosphere. So in the room, I think it's 0.04 ppm parts per million, 0.04%. In this room, we've been breathing in a while. There's not much ventilation. That's probably rising up to like 0.08. If it gets to 0.1, you start to maybe feel the effects like in your head because our lungs need oxygen, not carbon dioxide. It actually can steal some of that. If you're in a long car trip, you get up to like 0.1, you might feel a little bit wheezy, open the windows a little bit. In our atmosphere, over the last 200 years, we've raised that we've raised up to about 0.045. About 150 years ago, it was like 0.02. So we've roughly doubled the amount of carbon dioxide in the atmosphere over the last 150 years since the Industrial Revolution and the burning of hydrocarbons. Hydrocarbons, it's a fancy term for like oil, burning wood. All these things are CH4. Remember chemistry, high school. I didn't take chemistry class in college. CH4, that's one carbon, 4 hydrogen. If I burn that, CH4, if I burn it, that means I'm heating it up and letting it pair with oxygen. And so I get 2 H2Os because I stole 4 hydrogen from the C4 or CH4. So you get H2O, and then you take the carbon and another oxygen, you get carbon dioxide. So the result, if you burn gas in your car, there's other particulates, but largely it's water in the form of steam that comes out your tailpipe and carbon dioxide. Now, cars haven't had a significant effect. It's been factories that are really kind of changing that carbon number that we measure. That has taken place over the last 150 years. It produces an incredibly efficient source of energy. And we've relied on that for all sorts of, massive advancements in human quality of life improvement. Infant mortality has reduced substantially since the 19th century as a result of this. We've powered a huge American explosion. We've lifted so much of the world out of the lower class into the middle class, not just in America, but across the developing world. A lot of that happening right now. I'm a huge proponent of all that energy. It's made things in life much better. I'll just be totally, completely honest with you guys. I had twins born 3 years ago, very early. Medical advancements are amazing, and you're not gonna see me stand up here and say, we shouldn't have industrial revolutionized, we shouldn't have enjoyed all these benefits. One thing we did do, well, we roughly doubled the amount of carbon dioxide in the atmosphere, and that very predictably rose global average temperatures like 1 Celsius. Okay, well, like 1, maybe 1.5, we disagree, different scientists, just scientifically. Well, what that's done is it's kind of moved rainfall patterns around a little bit. It's probably increased the probability of heat waves in the summer to some degree. We think we're seeing more heat waves than we used to because we've just kind of lifted the tide up by like 2 degrees Fahrenheit. So the heat waves we get now are like 2 degrees Fahrenheit above what they used to be. Evaporative demand gets nonlinear, so you're starting to evaporate faster at 106 degrees than 104. You might have more drought pressure as a result. It hasn't been disastrous, but it's something we have to keep an eye on. I would say this much. If you told me right now, Matt, do you want to burn and double 0.04 to 0.08 over the next 150 years, I would pump the brakes a little bit, because now you're talking another maybe 2 Celsius. You're getting up to like 4 to 5 degrees. Now we have some problems that might start showing up. What those are exactly going to be is a huge matter of scientific debate. It's not political debate. We just don't quite know. We have all these climate models we run into the future to try to figure out what's going to happen. Are sea levels going to rise? Or the ice cap's going to melt? What have you? I can tell you if it goes from 0.04 to 0.08, I'm a little bit concerned. So I think we should just, I'm not a politician, I'm a meteorologist. There's reasons to enjoy the energy we've had. There's concerns about doubling it again over the next 150 years. But to be on one side or the other, yelling at the other, saying, I know the exact answer, just seems a little bit silly to me, given all those facts. That's a very long answer to a short question. Does that answer it? If you guys have any more questions, you want to come up, talk to me one-on-one, I'll be in the back there. But thank you for listening to 108 slides and the questions here this morning. Love you guys in South Dakota. Hope to be back. If that forecast I gave you is wrong, maybe I won't be invited back next year, but nonetheless, you guys have been pretty nice to me, so I appreciate it. Thank you.